In this video, I'd like to talk about the math question of the day for Sunday, May 21st, 2023. And with this example problem, we need to evaluate the improper integral if it exists. And improper integrals are typically taught in a Calculus 2 class. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start working through it. And you might be able to notice an issue with the domain of this function. We have 1 over the cubed root of x. But if we evaluate x at 0, then we end up with division by 0. So with this function, x cannot be 0, and we are evaluating our integral between the bounds of 0 and 8. So we have a bit of an issue here. But if we replace this lower bound with a letter and then take a limit as x approaches 0 from the positive side, since we're dealing with the interval between 0 and 8, we will approach 0 from the positive side, then we can actually try to evaluate this integral. So let's rewrite this as the limit as, let's say, a goes to 0 from the right side, the positive direction, of the integral from a to 8 of 1 over the cubed root of x, or we can write it as 1 over x to the 1/3 power, and we have dx. And to actually evaluate this integral, let's first move x into the numerator and give this a negative exponent. So we'll rewrite our limit here as a goes to 0 from the right of our integral from a to 8 of x to the minus 1/3 dx. And now we can just use the power rule for antiderivatives. So let's continue working over here. We still have that limit as a goes towards 0 from the right-hand side. But now we can actually compute this integral. We add 1 to the exponent, or 3 over 3. So we get x to the 2/3. And then we divide by that new exponent. So we're dividing by 2/3, but that's the same as multiplying by 3 over 2. And we evaluate this expression here between the bounds of a and 8. So let's start with this upper bound. We can plug that in. And I'll just rewrite the limit expression. Limit as a goes towards 0 from the right-hand side. And plugging in 8, we take a cubed root of 8 and then square it. The cubed root of 8 is 2, and 2 squared is 4. So we get 3 multiplied by 4 divided by 2, which we can simplify since 4 over 2 is just 2. So this all becomes 3 times 2, which is 6. So let me just rewrite this as 6. And then we subtract this expression evaluated at the lower bound, which is a. We have 3 multiplied by a to the 2/3 power, all divided by 2. And at this point, we can actually evaluate this limit. As we let a approach 0 from the right-hand side, it's a to the 2/3 will approach 0. And then we'll have 3 times 0 divided by 2, which is just 0. So this looks to be just 6 because this expression tends towards 0 as a gets closer and closer to 0 from that right-hand side.